Alright guys, so now we are going to talk about, we had finished the last screencast talking about strong acids and strong bases. Okay, and one of the important things to note about them is that solutions of strong acids or strong bases, these will have a higher conductivity than a weak acid, weak base solution with the same concentration. So the conductivity will be higher than solution of weak acid or weak base, same concentration. I don't feel like I'm writing very nicely for you guys, I'm sorry. Same concentration, okay? The other thing, so it's kind of the question is asking how can you tell difference between a strong acid, strong base solution from a weak acid or a weak base. So you're comparing a strong acid to a weak acid or a strong base to a weak base. The other way to do it, your delta heat of neutralization will be different. Okay. You cannot use the amount of base or acid to neutralize it because that would be equal for the same volume and concentration. Okay, so you're really looking at conductivity, heat of neutralization to tell the difference between a strong acid and a weak acid or a strong base and a weak base. You cannot use the amount of acid or base to neutralize because that is only based on the number of hydronium ions or the number of hydroxide ions. Alright, so now let's talk about pH. Okay, definition of pH is the log of the concentration of the hydronium ion. Remember those brackets, meaning concentration or molarity. Right? So if you want to find the concentration, concentration of the hydronium ion, that would equal 10 to the negative pH. At 25 degrees Celsius or 298 Kelvin, the concentration of the hydronium ion in pure water excuse me, is equal to 1 times 10 to the negative 7 molarity. And that's pure water. Okay, remember that water is going to set up an equilibrium with hydronium ion and a hydroxide ion. Remember the pH scale obviously is logarithmic. So if the concentration of hydrochloric is 0.1, pH is equal to 1. If it is equal to 0.001 molar, the pH is equal to 2. Also remember a change of 1 on the pH scale is a 10-fold change in concentration of hydronium. Okay, in describing whether a solution is very acidic to very basic, we're going to look at the pH. Wow, that's supposed to be a D. Jeez. Description of solution. Okay, and the color on universal indicator solution. So if my pH is 0. It is described as very acidic. And the universal indicator will show red. pH of 4 is determined acidic. Universal indicator will be orange. pH of 7 is neutral. Universal indicator will be green. pH of 10 is described as basic. Indicator will be blue. pH of 14 is very basic. And universal indicator will be purple. Don't know if you need to memorize that or not, but maybe it'll help you with some weird multiple choice question. All right, let's talk about acid rain. Okay, rain is naturally acidic, and that is due to the CO2. It reacts with CO2 as it falls. Okay, and remember that CO2 is a non-metal oxide, and remember non-metal oxides with water form acids, metal oxides with water form bases. Okay, so rain is naturally acidic because the water reacts with the CO2 as it falls, but this is only weakly acidic. Okay. So even if that rain was completely saturated with CO2, the pH would only be about 5.6. Okay. Acid rain is defined as rain with a pH less than 5.6. Okay, so where does this acid rain come from? Well, there are two main reasons why acid rain is formed. All right. Okay, so two main reasons why acid rain is formed. The first reason is because of release of SO2, sulfur dioxide, from burning fossil fuels. Okay, things like coal that have sulfur in them. Right? Also from smelting of sulfide ores. So basically what happens is we have the sulfur dioxide reacting with water to form sulfur trioxide. Sulfur trioxide then reacts with the water in the air to form sulfuric acid. Right? Again, non-metal oxide forming acids. All right, second reason for acid rain to form is the release of oxides of nitrogen. Things like nitrogen dioxide. And these are from jet engines or internal combustion engines. That's or internal combustion engines. Okay. And these have to have a high enough temperature to form nitrogen oxide. So basically we get two nitrogen monoxides reacting with oxygen to form two nitrogen dioxides. Those nitrogen dioxides then react with water to form nitric acid and nitrous acid. Okay. So why is this a problem? Well, it is actually a world, spell that right, worldwide problem. Because the precipitate, the acid rain, is going to, can travel miles away from the source. Okay. This will cause damage to buildings. And this is typically because of limestone or calcium, or the carbonates that are in building materials. Because acids with carbonates form water and carbon dioxides. It can also leach important minerals from the ground. That's minerals from the ground. Okay, and this will affect vegetation. Okay. It can affect aquatic life. By altering the pH of rivers and lakes. And human health. Okay, it increases risk of respiratory disease. Okay, the next screencast will be on calculations.